Hello everyone, I am Siddharth Kamnan, a third year student at Tatasaheb Kore Institute of Engineering and Technology. Today I will be providing the project that I have worked during the internship at Emertxe. I would like to thank Emertxe for giving me this opportunity. During this internship, which is of 4 weeks, I was able to work on the project IoT based home automation under the guidance of Jayalakshmi and Dhanal ma'am. During these 4 weeks, we learn about C programming, Internet of Things, embedded systems, and microcontroller. We will be going through overview, objectives, design elements, and simulation, and the conclusion of the project. Let's move to the introduction. The aim of this project is to automate the household appliances remotely using Internet of Things. The devices are connected using Arduino Uno and Blynk application. This simulation is demonstrated using Pixlim Lab before its hardware deployment, so that this project offers portability, efficiency, and scalability for smart home systems. In the first week, we learn about the C programming. The C programming is a general purpose language. It has many applications. It is widely used in embedded system because of its efficiency and control. Here, a code is given. Let's discuss its components. Here is a file header, that is my first C code. Let's move on to the preprocessor. Hashtag include studio is the preprocessor. The code begins using the int main where the program starts. In the bracket, we can see the very first line is to display the hello world. Well, it is displayed by a comment. Comment is a non executable statement used for the reference of the user in C programming. We will be using the printf statement to print or display the result. A return 0. It is a program termination block. Now let's move on to the topics we have discussed in C programming. In C programming, there are data types. Data types are a variable that holds a command. They usually determines the size and layout of a variable memory. There are different types of data types like character, float, etc. Let's move on to the modifiers and quantifiers. Modifiers like short, long, signed, and unsigned. These are the keywords that alter the size or sign of a basic data type. Quantifiers like constant and volatile modify the properties of variables, such as preventing its value from being changed after initialization. Conditional statements. The conditional statements are also known as decision making statements. They usually has the task of control the flow of a program and check whether the condition is true or a false. There are different types of conditional statements like if else, else if, switch, which has certain tasks that is being performed by a specific block of code depending upon the situation we use. Like switch is used to switch between the different types of block of codes depending upon the situation provided by the user. Now let's move on to the loops. Loops are the control flow statements that are used to execute a block of code repeatedly or depending upon the instruction we have provided. There are different types of loops like while, do, for. It has certain specification task and it performs as per its requirement. Now let's move on to the operators. Operators are the symbols that tells the compiler to perform the task, like whether it is mathematical, relational or logical operation on variables and values. There are different types of operators like arithmetic operator, relational operators and logical operator. Strings. Strings is a sequence of characters stored in a one-dimensional character array and is always terminated by a null character. C does not have a built-in string data type. So the strings are handled as array of characters. Usually we use string.h library for it. Now let's move on to the functions. Functions is a block of organized reusable codes that performs a specific task and runs only when it is called. Function makes program modular and easier to read, debug and maintain by breaking them into smaller pieces. Like a big chunk of task is broken down, or we can say a complex task is turned into smaller manageable pieces such that it will be able to execute the code very efficiently. Storage classes. Storage classes define the scope, lifetime and storage location of variable within a program. There are four main classes: auto, static, register and extern. These are the different classes of storage classes. Preprocessor. The preprocessor can be defined as the program that performs the code before the code has been begun. Like we have previously discussed a sample code, how a program is executed in C. So hashtag include is inserting header files. Now let's move on to the importance of C and its application. C is a rich set of built-in functions. It is well cited for writing both system software and business packages. The C compiler combines the capabilities of an assembly language with the features of high-level languages. Let's see the application. Usually the C has a very wide range of applications. We will be discussing its two important applications. It is used for the game development. We can develop different games, small scale games by using C. Now let's move on to the another application, that is it is used for development of operating systems. Let's see the IoT, that is Internet of Things. Let's see the definition. The IoT is a network of physical objects with embedded sensors or softwares and other technologies that are connected, and the data is exchanged over internet without direct human input. To be simplified, it is the IoT is the connection of a network like embedded sensors, software, or any other technology, and they are being connected to each other by internet, and they have task for like exchange of information through it, and we can term it as IoT. Let's see the importance of IoT and its application. As we have previously discussed, it has wide range of applications. Few of them we will be discussing now. It is used in healthcare, automobile, logistics and transport businesses. Its examples are wearable devices, smart cars, smart buildings, and home automation. We are surrounded by most of the IoT applications. In everyday basis, we are using IoT devices. Home automation. We will be discussing this in detail. And embedded system. The embedded system can be defined as it is the combination of computer hardware and software designed for the specific function. The embedded system uses the communication ports to transmit data between the processor and peripheral devices, often other embedded system using a communication protocol. Generally, they comprise of a processor, power supply, memory, and communication protocol. Now let's move on to the application of embedded systems. Usually, it has wide applications. We will consider few of them like CAT scanner, electric vehicle, washing machine, and embedded system. These are the examples of embedded system application that we are using on everyday basis. Let's move on to the microcontroller. In that we have learned about ADC block. ADC block, it is analog to digital converter that usually converts the analog signal into digital. DAC block, that is a digital to analog converter that usually performs the opposite function of that ADAC block. That is, it performs conversion of digital values into analog signals. Timers and counters. Timer is a dedicated hardware module that counts up and down at a specific frequency. It is used for generating time delays. And a counter is similar, but typically it is used to count external events such as pulses from the sensor. PWM, which stands for pulse width modulation. It is a technique used to control the power delivered to a device by rapidly switching the power source on and off. Preprocessor, memory, and input output ports. The preprocessor is the brain of the system executing the instruction which we provide. Memories like RAM, ROM stores the data and the instruction. Input output ports are the physical devices which are connected to the other devices externally. Microprocessor and versus microcontroller. A microprocessor is a single chip CPU that requires external components like memory, timers, and input output ports to function, whereas a microcontroller is a single chip computer that integrates the CPU memory and input output peripheral onto a single integrated circuits. RAM stands for random access memory, is a volatile memory used for temporary storage while the device is running. ROM, which stands for read only memory, is a non-volatile memory that stores permanent data and programs instructions. There are the types of ROM include PROM, EPROM and EEPROM. Let's see the project objectives. The objectives of projects are to design an affordable IoT based home automation system, simulation and verify working using the Pixlim Lab simulation app, enable remote appliance control through smartphone Blynk app, understanding the IoT in architecture, data flow and real-time device monitoring. Let's see why there is need of home automation. When we look like time saving and convenience over the manual work, home automation is required. For the accessibility and comfort of ourselves, we will be using the home automation. To deliver the efficiency, we will be using the home automation. By using the automation, it will be able to provide the feedback. There will be increased in efficiency and there will be cost reduction. Let's see what components we have used in this project. Here components like Arduino Uno, a Wi-Fi module slash an Ethernet, relays, resistors, LED indicators, cooler, heater sensor and LDR sensors are being used. Actually, we have used these hardware components in simulation app. In the software, we have used different types of softwares like Arduino IDE for the programming of Arduino Uno, Pixlim Lab for the simulation of the project, and Blynk mobile app for the control of the project. Arduino Uno. Arduino Uno is a microcontroller board based on the Atmel 3208P. Arduino Uno has 14 digital input output pins. 6 can be used as PWM outputs. It consists 6 analog input output pins, a 16 Hz ceramic resonator, a USB connection, a power jack, an ICSP header and a reset button. The Arduino we used is Uno board and that can be programmed using Arduino IDEs for this project. Here is the image of Arduino Uno, Pixlim app and Blynk application. Pixlim app is a open source real-time emulator of deployment boards with integrated MATLAB's ever GBD debugger. It has integration with Arduino IDE for programming the board's microcontroller. Whereas Blynk application is IoT platform. It is an app that is used to control the Arduino via internet. We understood that to create new templates, how to add new devices, how to add GDD and select and add a new data stream. We have learned how to create uh, icons and Blynk lib by using Blynk library, which is included in the app. LDR. LDR are the tiny light sensing devices known as photoregisters. An LDR is a register whose resistance changes as the amount of light falling on it changes. The resistance of a LDR decreases with an increase in light intensity. This property allows us to use them for making light sensing circuits. The LED light are connected to a LDR via ADC. The ADC converts the analog input by the LDR into its equivalent digital form, which is converted later by certain formula from 0 to 255 as upper bound. Based on that, we glow the LED. Garden lights control. The properties of LDR sensors are applied to accomplish the controlling of garden lights. During the day, the outdoor light is maximum, so the LDR sensor detects the light and the garden light is turned off. Whereas at the night, the outdoor light is very low, so the LDR sensor detects the light and the light is turned on. Let's move on to the temperature sensor. The temperature is recorded using LM35 sensor, which reads analog values. The values converted into binary values and later actual temperature is calculated using the obtained actual value of voltage. This sensor doesn't require any external calibration to provide accuracies in the result. Temperature control system. The temperature control system consists of a heating resistor, an LM35 temperature sensor and a cooler. Analog value of a temperature is obtained from the temperature center, that is LM35, and displayed on the CLCD after converting it into digital value using ADC. The temperature is control system is controlled by a Blynk app. Here is the supporting diagram. Water inlet and outlet valve control. It reads the volume of water in the tank through serial communication and display it on the CLCD. It controls the value of water in the tank by controlling the inlet and outlet valve flow by sending the command through serial communication, and it will display the volume of the water in the tank on the CLCD display, and also simultaneously it will be shown on Blynk app. Let's see the simulation image. Here is the simulation image. Here are the components we have used. Here is the Arduino, here is the serial tank. Here is the LCD display, CLCD display. Here is the cooler, here is the Ethernet, here is the LDR, and here is the LED. Let's move on to the advantage of this project. It is a low cost and scalable. It operates via mobile application globally. It requires minimal human intervention. It is verified virtually to ensure the safety of the components. It has wide range of applications like for smartphone systems. Here we can add different types of components to it. It can be used in industrial automation. It has application like smart classroom or lab environments that can be converted through app. A remote energy management system. Conclusion: we have successfully designed and implemented a home automation system. Project validated using Pixlim Lab and deployed using Arduino Uno plus Blynk application. It provides a foundation for scalable and AI-ready smart home automation system. Now we are done with the presentation. We will move on the demonstration part. You can see here we have connected and our project is working. So here we can see the interface of the app. Here we will be uh, starting the outlet valve. You can see here once we started the outlet valve, the water level drops down, which is displayed here. We can start the inlet valve by clicking on. As you can see here, the water tank has started filling. We can stop here. Now let's start the heater. The heating has started and which is displayed here. Heater has been started. The temperature has been starting the rising. We will be stopping here. Then we will be starting the cooler. As we can see here, the cooler has been started and temperature has been starting to drop, which can be clearly seen here. Okay, we will stop here. Then here is the LD sensor. Once it decreases its light, the light goes off, such that it has, considering it as it is a morning. Once we begin, here's the brightness increases. So here again, here in LCD we can see, here we will start the cooler. You can say the cooler has been started. We will stop here. Here we will starting of the heater. Heater will start. Here is the serial out here. Once we start, the inlet valve will start and water will start filling. Here we can turn it off. Later we can switch on the outlet valve, and water will, its volume will start to decrease, and its volume will be clearly displayed here. This is all about the project that we have learned. Thank you.